Hey YouTube, welcome back. Today we will talk about clusters and cluster databases, what they are and why do we need them. So, a cluster database, often referred as a cluster database system or a database cluster, is a specialized database architecture that involves multiple interconnected database servers or interconnected nodes working together as a single unit. The primary goal of a cluster database is to improve performance, availability, and scalability of database services. So, as you can see right now, all of these nodes are working together at one unit, and all of them they are connected with each other. And there are some characteristics that we need to know about these type of things. So right now we know what is a cluster. A cluster is a set of nodes or set of servers which are connected together and behave as a single unit. And the primary goal of them is to improve performance, availability, and scalability of the database. So, okay. So we have to answer two questions more. What are the characteristics of the system, and what are the benefits, and why do we need it? So let's go here. Let's talk about the characteristics first. Oh, sorry. And the first one that I would love to talk about, which is the distribution of the data. Sorry, guys. The distribution of data. So, in a cluster database, let's go back here. In a cluster database, data is distributed across multiple nodes or servers. Each node typically contains a subset of the data, and the data distribution can be organized in various ways, such as sharding, replicating, or partitioning. So the data is the first thing, that how data is being stored and how data was being distributed. We it's been in various way. We said that sharding or maybe replicating. We have each replicas, like we replicated the data across all the nodes. Maybe we have sharding, so each node have a specific part of the data, and etc. So let's talk about a second thing, which will be the parallel processing. So clustered databases enable parallel processing of queries and transactions. Multiple nodes can handle required requests simultaneously, which can significantly improve the overall performance and response times of database operations. So we have three nodes here. We could, instead of one node, take three requests all the time at one time. We can have each one node here can take one request. So right now we are making parallel processing. Each node can serve requests. Each node can serve servers or clients. Other thing that it's quite you can see quite obvious. It's how high available is the clusters are. So one of the key reasons for using clusters databases is to enhance availability by distributing data across multiple nodes. Clustered databases can continue to provide service even if some of the node fail. This high available is essential for mission critical application that require uninterrupted access to the data. So if node 1 was down, node 2 and node 3 could still serve, and when node 3 is down, we have node 2, etc. So we are available all the time. And from all the past three sections, we can say that the clusters are scalable. So clusters databases can be scaled both vertically by adding more resources to each node, and horizontally by adding more nodes to each cluster. Horizontally, scalability in particular allows databases to handle growing workloads by simply adding more nodes. As you can see here, we can add more resources, or maybe you can add more nodes if we want. 5, which will be, I would say 5, it will be the load balancing, but we already said that in the parallel processing, but let's just say again. So cluster database often incorporate load balancing mechanism to distribute incoming requests evenly across the nodes. This ensures that no single node become a bottleneck that resources are used efficiently. So let's talk about why do we need cluster databases? So we need them in performance improvement. This is the first thing that we need because it improves the performance. So clustered databases can deliver higher levels of performance compared to single server databases. They can handle larger datasets, support more concurrent users, and process queries faster due to parallel processing capabilities. Also, the second thing that why we need sorry guys, why we need cluster is the high availability and fault tolerance. So clustered databases offer improved fault tolerance. If one of, as you can see here, if one of the node fails, other can continue to serve requests, reducing the risk of downtime and data loss. This is crucial for applications that require continuous access to data. Number 3 that we get from cluster is the scalability. So as organizations and applications grow, the demand for database resources also increases. Clusters databases allow for easy scalability by adding more nodes. As you can see here, we can just add more nodes if we wanted to scale our system. So clustered databases allow for easy scalability by adding more nodes to the cluster, ensuring that the database can handle increased workloads without performance degradation. Also, we need it in data distribution. Oh, sorry, this is wrong. Sorry guys, I'm still ill. So some applications require data distributed geographically to reducing latency, for example, or meet regular requirements. Cluster databases can distribute data across multiple data centers for regions while maintaining data consistency. So let's say that we want to make sure that data is available all the time, so we can just replicate it or just distribute it across multiple data zones to make sure that it's available most of the time. It's also great when it comes to data backup and recovery. So cluster databases often include backup and recovery mechanism to ensure data integrity. Redundant copies of data can be maintained across nodes, allowing for quick recovery in case of data corruption or loss. So, in summary, cluster databases are designed to address the limitation of single server databases by providing improved performance, high availability, scalability, and fault tolerance. They are especially valuable for applications with demanding requirements in terms of data volume, user concurrency, and availability. So that's it for this video, and I hope you like my content. If you like my content, subscribe and hit the notification bell so you never miss a video, and see you guys in future problem.